This video will help you with your Module 2 Assignment 2.03, Real Zeros of Polynomial Functions. So the first question says, divide f of x by d of x and write a summary statement in the form indicated. So they gave us f of x here at the top, and they gave us d of x here at the bottom. So I'm going to write it old school. So remember the old school division symbol? Kind of like this. So I'm going to put my f of x underneath the radicand, so x to the fourth plus 5x to the third minus 2x squared plus 5x minus 3, and it's being divided by x squared plus 1. So this is called polynomial long division. So if you need any additional video resources and you're searching YouTube, Khan Academy, or any other outside resources, search for polynomial long division for additional examples. What we're going to do is we're going to take the first term, which is x squared, and ask yourself how many times it will go into the first term, x to the fourth. Well, I know that will go in x squared times, because x to the second times x to the second is x to the fourth. So if you think back to how you used to do division, you would multiply these two together and subtract it down here at the next step. But you got to remember, you've also got to do it to the plus 1. So x squared times 1 is x squared. So what I'm going to do, let me not put it there, I'm going to line it up underneath the x squared term. I'm going to draw my line. These guys will cancel out. The 5x to the third will come on down. And then negative 2x squared, remember it's minus x squared because you're subtracting, is going to be negative 3x squared. Okay, let's shift colors again. Now I ask myself, how many times will x squared go into 5x cubed? Well, I know it will go in positive 5x times. Because 5 times 1 is 5, and x times x squared is x cubed. So now I can subtract 5x cubed. Just don't forget I also have to do it to the 1. So 5x times 1 is 5x. And remember, that's going to be subtraction, so we're going to minus 5x. Draw my line. Negative 3x squared, there is nobody similar to it, so it just comes on down as it is, negative 3x squared. And then you've got this 5x up here. That comes down. 5x minus 5x is 0. And then the negative 3, you can go ahead and bring it down to at this point. So now ask yourself, how many times will x squared, let's change colors for good visuals here. Nice pretty green. We go to x squared, how many times will it go into negative 3x squared? Well, it will go in negative 3 times. Negative 3 times x squared is negative 3x squared. And negative 3 times 1 is negative 3. But remember, you are subtracting, so really you're adding, so it's going to make that one go away. In this case, at negative 3, you're adding 3, and that also will make it go away to become 0, meaning no remainder. So you end up with an answer of x squared plus 5x minus 3. That is what it divided out into. So the way the question will want it on the test or the assignment is to actually put it in an original form, which means they want you to know how to multiply it back. So you're going to take this x squared plus 1 and put it as part of your answer. So your final answer should be x squared plus 1 times your x squared plus 5x minus 3. Because when you distribute that back out, I'll come back out to my original answer right here. Polynomial long division can be a little tricky, so make sure that you check out additional examples if you need more help with those. Because then comes the next one, which is fairly easier. It's synthetic division. And the way synthetic division is, you take this first term, the one that's being divided, and write the coefficients out. So we got 3, -2, 3, -4. Then you take your coefficient, or not your coefficient, but your constant here at the end of this binomial, which is -3, and you're going to put it in this little kind of backwards L-shaped box, but you're going to put it as the opposite sign. So let me repeat that. You're going to put that as the opposite sign. So here it was -3, it's going to be +3 here. Don't forget that. If you mess that up, this messed the whole thing up. So here's what happens. You take your first number, and it just comes on down. Bring it to the bottom, 3. Then what you're going to do is you're going to multiply it by your number here, the box. So 3 times 3 is 9, and it's going to come right here. And what you're going to do is just add these two numbers together. 9 plus -2 is going to be +7. You're going to do the same process. 7 times 3 equals 21. And 21 plus 3 is 24. Then lastly, do it again. 24 times 3. So again, you're multiplying each number by that number in the box. 24 times 3 is 72. And that answer again comes back over here. 72 plus -4 is the same thing as just saying 72 minus 4, which is 68. So at the end, now you're like, what do I do now? Great question. What I like to do is start from the beginning and go one less than this one. So see how this is a 3, x to the third, so this one be x to the second, x, no x, and then this, whatever's at the end, is going to be the remainder, so you're going to put it over what you're dividing by. This was positive, positive, positive. So my answer is 3x squared plus 7x plus 24 plus 68 over x minus 3. And that's what the synthetic division will put out for you. I'll give you the answer right there. So then, as long as it is consistent, you can do it to find the remainder. So let's take a look at this one a little closer. Notice that it's x minus k, and they tell you that k is 4. So really it's this divided by k minus 4. So I'm going to use synthetic division, and it's a little easier and it's better practice for you. So I'm going to start with my little box. So if k is 4 right now, it's minus 4 in the problem. So then it's going to be plus 4 right here. All my coefficients are 4, -2, -4, 15. Draw my line. Bring the first number down. 4 times 4 is 16. 16 plus -2 is 14. And then we're going to do 14 times 4, which is 56. 56 plus -4, remember that's the same thing as 56 minus 4, which is 52. Then times 4 is 208. And 208 plus 15 is 223. So my first number here was 3, so I'm going to begin with 2. X squared, x, no x, and the last one is always my remainder, over k minus 4. These guys were all positive, so we are good to go. So 4x squared plus 14x plus 52 plus 223 over k minus 4. Then you're going to be asked to find out if a number is an upper or a lower bound. So they're going to give you a number. In this case, it says, is 2 an upper bound of the equation x cubed plus x squared minus 6x plus 12? All that's really asking you, let's put a 2 in our synthetic division and write out the remainder of the problem. So we got it set up. Bring the first number down to a 1. 1 times 2 is 2. 2 plus 1 is 3. 3 times 2 is 6. -6 plus 6 is 0. 0 times 2 is 0. 12 plus 0 is 12. Remember that our first number here was a 3, so my answer is going to be x squared, x, no x, and then remainder. We don't know exactly. Well, if it was, I don't know what letter they were, well, probably x, so it'll be over my remainder, probably x minus 2. But what they're asking you for is to an upper bound, okay? So because all of the signs here at the bottom resulted in having the same sign, so notice how it's positive, positive, positive. The answer then is yes, because it resulted in having the same sign. So let's look at the second question and see something a little bit different. It's now asking you for the lower bound of the equation. So I'm going to do the same thing. Set up synthetic division. Set my coefficients, 3, 4, 1, 3. Bring down my first number, always the first step. 3 times negative 1 is negative 3. Negative 3 plus 4 is 1. 1 times negative 1 is negative 1. Brings down and becomes 0. 0 times negative 1 is 0. And 3 plus 0 is 3. So now I'm asking myself, is it a lower bound? So the question is, are all the signs the same? If they are, yes, it is a lower bound. Then we're going to be asked to use the rational zeros theorem to write a list of all possible zeros of the function. So this one is the one from your lesson where you did P over Q. We look at our first number of 4, list out all the factors of 4. You got 1, 2, and 4. Those are all the numbers that can make 4. And then 14, got 1 can go into 14, 2 can go into 14, 7 can go into 14, and 14 can go into 14. So the one thing to remember about using this theorem is that you have to remember that everything is always plus or minus, because you can do the positives or the negatives. Just please keep that in mind when you write out your answer. So if I do P over Q, you've got 1 over 1, 1 over 2, 1 over 7, 1 over 14. You've got 2 over 1, 2 over 2, 2 over 7, and 2 over 14. Then lastly, you've got 4 over 1, 4 over 2, 4 over 7, and 4 over 14. And again, all of these, remember, are plus or minus. So we just need to simplify this a little bit. 1 over 1 is 1. 1/2 is simplified. 1/7 is simplified. 1/14 is simplified. 2 over 1 is 2. 2 over 2 is 1. 2 over 7 is simplified. 2 over 14 can be reduced down to 1/7. 4 over 1 is 4. 4 over 2 is 2. 4/7 is simplifying. And then 4 over 14 is 2/7 when you reduce it. And the reason we do that is now we can go back and eliminate any duplicates, because if you look closely, you've got a 1 here and a 1 here, so we don't need to list it twice. 1/2 is by itself. 1/7 is listed twice. We don't need it again. 1/14 is listed once. 2 has a second pairing here. 2/7 listed twice. So we don't need to list it out. So my possible zeros are plus or minus 1, 1/2, 1/7. It's like a 3, but it's a 1. 1/7, 1/14, 2, 2/7, 4, and 4/7. And those are all the possible rational zeros, using the rational zeros theorem, those are all the possible zeros that I could have based on this. Hope this helps you with your assignment, and good luck.